Your body is constantly fighting off invisible invaders, viruses, bacteria, you name it. And to do that, it has this incredibly sophisticated army, your immune system. But this army has one massive, critical challenge. It has to know the difference between a real enemy and you. So let's dive into this incredible balancing act.
This really is the million-dollar question, isn't it? If you think of your body as a nation made of trillions of your own cells, how does this internal army make sure it only ever attacks foreign invaders and never, ever turns on its own citizens? Well, the answer is a process that is just unbelievably clever.
Okay, so first, let's just lay out the fundamental problem. The immune system is constantly stuck in this high-stakes dilemma, trading off between raw power and pinpoint precision. I mean, think about it. On one hand, you need a defense force that is absolutely ruthless, right? It's got to hunt down and wipe out threats, no questions asked. But on the other hand, if that immense power is even slightly misdirected, it could cause a catastrophe, attacking the very thing it's sworn to protect. It's a huge, huge challenge. The biological answer to this whole dilemma has a name: self-tolerance. It's this amazing ability to recognize the molecular flags on your own cells, your self-antigens, as friendly, while still going after anything for it. It's basically the know thyself principle at a microscopic level, and it is absolutely vital. Without it, our bodies would be in a state of constant civil war.
Now, what's so wild is that the problem actually comes from the system's greatest strength. To be ready for any possible invader, our immune cells, called lymphocytes, create a massive, random library of receptors. This gives them the power to recognize almost anything. But anything, of course, includes our own body parts. So the very thing that makes the system so powerful is also what makes it potentially so dangerous.
So, how does the body deal with this built-in risk? Well, it doesn't just cross its fingers and hope for the best. It puts its soldiers through an incredibly rigorous training program to find and eliminate the potential traitors before they're ever sent out into the field.
This first phase of training is called central tolerance, and you can honestly just think of it as boot camp. It all goes down in the primary immune organs, the thymus for T cells and the bone marrow for B cells. This is where the raw recruits are put to the ultimate loyalty test.
Okay, let's look at the T cells. Their training in the thymus is unbelievably strict. First up, positive selection. The recruits have to prove they can recognize our body's own cellular ID cards, these things called MHC molecules. If they can't, they're useless, gone. Then comes the loyalty test. A special gene called AIRE lets the thymus show those T cells a huge library of our body's own proteins. And that leads to the final, crucial step, negative selection. Any T cell that grabs on too tightly to our own stuff is flagged as a potential traitor and is forced to self-destruct. Only the ones that get the balance perfectly right get to graduate.
B cells go through a really similar process, but they get this fascinating second chance. If a B cell is found to be self-reactive, it can try something called receptor editing. It literally gets a chance to shuffle its genes and build a totally new receptor, hoping this new one isn't a threat. But if that last-ditch effort doesn't work, it's eliminated too.
But look, no boot camp is 100% foolproof. The training is tough, but it's not perfect. So the body has a second layer of security, a whole series of checkpoints out in the tissues where the real action happens. And this is the critical what if. No system is perfect, right? So a few rogue cells, these autoreactive lymphocytes, are bound to slip through the cracks and get out into the body. What stops them from starting a war?
Well, that's where this backup system, peripheral tolerance, comes in. It's a whole set of safety switches designed to find and neutralize any of those rogue cells that escape the initial boot camp. It's kind of like the secret service of the immune system, working silently to prevent disaster.
And this image here shows exactly how it works. When a T cell meets an antigen out in the wild, its fate can go one of 4 ways. And what's key is that 3 of those 4 are safety overrides. So here's the deal. A normal response, activation, that's only for legitimate foreign threats. If a T cell tries to react to one of our own antigens, this safety net just snaps into place. One of 3 things happens. First, the cell can be switched off, put into a state called anergy, where it's totally unresponsive. Second, the cell can just be ordered to self-destruct. That's deletion. Clean, simple. Or third, these special peacekeeper cells called regulatory T cells can swoop in and actively block it from doing anything. That's suppression. So you've got anergy, deletion, or suppression. 3 powerful ways to stop friendly fire before it starts.
But what happens when this beautiful, complicated system of checks and balances finally fails? Well, the consequences can be devastating.
You end up with situations where the body's protectors either turn into its attackers or just abandon their posts completely.
When the system breaks, it usually goes in one of two opposite directions. On one side, you have autoimmunity. That's friendly fire. The system becomes overactive and attacks the body. On the other side, you get immune paralysis, where the system is so suppressed, it basically stands down, leaving you completely vulnerable.
So autoimmunity is the most direct result of self-tolerance failing. It's what happens when those rogue cells we were talking about not only escape boot camp, but also manage to dodge all the checkpoints in the field and start launching attacks against our own tissues.
And these attacks can be really specific or they can be widespread. In organ-specific diseases like type 1 diabetes, the immune system goes after a single target, in that case, the pancreas. But in systemic diseases like lupus or rheumatoid arthritis, the attack is all over the place, affecting tissues and organs throughout the whole body.
Okay, now let's flip to the other extreme. The complete opposite of that hyper-aggressive state is immune paralysis. It's a really dangerous condition where the immune system just shuts down.
You often see this in really severe conditions like sepsis. And it's a total paradox. The body is on fire with inflammation, but at the exact same time, its immune defenses are being profoundly shut down. It's just a chaotic, dysregulated mess that's incredibly dangerous.
And you can literally see the biological signs of this shutdown. T cells just get exhausted and stop working. Production of key messenger chemicals, cytokines, just tanks. The actual number of lymphocytes in the blood plummets, and you see a huge increase in these off-switch molecules like PD-1, which is like slamming on the brakes for the whole system.
So, as you can see, this whole thing is this extraordinary, high-stakes balancing act. It is a constant walk on a tightrope. You lean too far one way, you get the self-destruction of autoimmunity. You lean too far the other way, and you're left defenseless by immune paralysis.
Staying healthy is all about keeping that perfect balance day in and day out. And it kind of makes you think, doesn't it? In a world that often feels full of extremes, maybe the body's greatest wisdom is its constant, incredible pursuit of balance. What can we learn from that?